You know that black screen with a little blinking cursor? The one that can feel a little intimidating? Well, that's the Linux terminal. And trust me, it's not something to be scared of. It's actually one of the most powerful tools you can have in your toolkit. So today, we're going to focus on that core 20% of commands you'll end up using 80% of the time. We're going to turn that fear into a legit superpower.
So here's the plan. It's pretty simple, actually. We're going to demystify this whole command line thing by jumping into a real-world problem. And I promise, by the end of this, you're not going to see the terminal as some scary barrier. You'll see it for what it is, your fastest, most direct way to solve really tricky problems.
All right, let's set the scene. I want you to imagine this. You're a junior engineer. Your pager goes off, or, you get that urgent Slack message. The main application is down, all eyes are on you. You've just SSH'd into the server. Your mission, should you choose to accept it, is to use nothing but the command line to figure out what's wrong and get it back online.
Okay, so every good investigation has to start somewhere, right? Our first couple of questions are super simple. Where exactly are we and what's around us? Before we can find the problem, we have to get our bearings in the server's file system.
So, first things first, we need to figure out exactly where we are in this maze of directories. It's kind of like looking for that "You Are Here" sticker on a mall map. We need our starting point. And to do that, we're going to use our very first command, pwd. It stands for Print Working Directory. You type it, hit Enter, and bam, the terminal tells us we're in /root. Now, /root is the home folder for the main admin user, which is fine, but it's not where our application files are. We need to go somewhere else.
Now, we happen to know, maybe from some documentation, that the application logs, which are our first set of clues, live over in /var/log/application. So how do we get there? We use the cd command for change directory. We type it in, and just like that, we've teleported right to where the action is.
All right, we've arrived at the scene of the crime. So what's the next logical step? We got to look around, right? See what files are in here. Are there logs? Are there any clues at all that can point us in the right direction?
To do that, we're going to use ls-l. So ls just lists the files. But that little -l flag, that gives us the long format. It's a much more detailed view that shows us things like permissions, who owns the file, and most importantly for us right now, the file size. And look at that. We spot our first real clue, a file called error.log. And you see that size? It's not 0. That tells us something important is written inside.
Okay, so we found an error log. That's great. But here's the catch. Log files can be absolutely massive, like thousands and thousands of lines of just noise. So our next job is to cut through all that static and find the actual clues we need to solve this thing.
So your first instinct might be to just dump the whole file onto the screen, right? And for that, we can use the cat command. But whoa, as soon as we run it, we just get this giant, overwhelming wall of text scrolling past. There is no way we can find anything in there manually. We need a much, much smarter tool.
And that smarter tool is the pipe. It's that vertical bar character on your keyboard. Honestly, this is a real game changer in Linux. The pipe lets you chain commands together. Think of it like this. It takes whatever comes out of one command and sends it directly into the next command as its starting material. It's like an assembly line for your data.
Let's see this thing in action. On one side, you have that total mess from just using cat. But on the other, watch what happens when we use a pipe. We take the output of cat error.log, add the pipe symbol, and feed it into another command called grep. Grep is basically a search filter. We tell it to look for the word database, and boom, just like that, all the noise is gone. We only see the lines that actually matter, and it looks like we've got a connection issue with the database. Okay, this is huge. These findings are critical. So we've managed to isolate the key error messages, and we've saved them into their own little file. But before we do anything else, it's always a good idea to make a backup. We're going to use the cp command for copy to make a copy of our findings and put it in a safe place. Okay, our evidence is secure. The hunt continues.
All right, here's what we know. The app can't talk to the database. The error logs are screaming about a connection refused error, and they're pointing specifically at port 5433. So now our job is to find the smoking gun, the exact piece of configuration that's causing all this chaos.
We have a strong suspicion that a config file somewhere has the wrong port number. The problem is we have no idea where that file lives. So what do? We use the find command. This thing is awesome. We can tell it to search the entire file system, starting from the very top, that's the slash, and look for any file whose name ends in db.conf.
And would you look at that?
The find command comes back with two results, right next to each other, db.conf and db.conf.backup. That backup file, that's a massive clue. It practically screams that someone made a change here recently.
So what exactly was the change? To find out, we can use a really cool command called diff to compare the two files line by line. And there it is. That's our aha moment. The output from diff shows it plain as day. The port number was changed from the correct 5432 to 5433. I think we found our culprit.
Okay, we have a really strong theory now. The app's configuration is just plain wrong. But hey, before we rush in and start changing things, let's do one last sanity check. Is the database itself even running on the port we think it should be? Is it actually listening on the correct port, 5432?
We can check this really easily with curl, which is a great little tool for making network requests. We'll just ask it to try and talk to our own machine, that's localhost, on port 5432. We run it, and we get a response. Success. Postgres is up and running and listening on the right port, so our theory is 100% confirmed. The problem is definitely that config file.
So, we found the root cause. Now it's time to put on the hero cape and actually fix this thing. All we have to do is edit that one configuration file and change the port number back.
Okay, let's use a classic command line text editor, vim, to open up the file. We go in, we find the line, but when we try to save our change, we hit another wall, a read-only file warning. We can't save the fix. This isn't a bug, by the way. It's a very common safety feature on live systems, and it all comes down to something called file permissions.
Let's take a quick look at this. In the Linux world, every single file has a set of permissions for 3 different categories of people: the user who owns the file, a group of users, and then just other, basically everyone else. And for each of those, you can have permission to read, write, or execute. It's often shown with numbers. 4 means you can read it, 2 means you can write to it, and 1 means you can run it. And the problem right now is that our user only has permission to read this file, not to write to it.
So getting this fixed is a simple 2-step process. First, we need to change the file's permissions using the chmod command, which stands for change mode. We're going to run chmod 600db.conf. Now that 6 is just 4 plus 2, giving the owner read and write permissions. The 2 zeros take away all permissions for the group and for everyone else. It's much more secure. Once that's done, we pop back into the file with vim, change the port back to 5432, save it, and problem solved.
And just like that, you did it. You went from a junior engineer staring at a critical error to the person who methodically tracked down the issue, navigated the system like a pro, and deployed the fix. All from that scary black screen. You see, you didn't just fix a bug. You wielded a new superpower. So the only question left is, what are you going to solve next?